Welcome back. Today we're going to do another island matrix problem. Today's problem is 1, 2, 5, 4. Number of closed islands. We are given a 2D grid consists of zeros and ones. The zeros are lands and the ones are waters. An island is defined by a group of lands linked horizontally and vertically. A closed island is an island that is surrounded completely by water on all sides. So let's take a look at one of the examples they provided. So for example, this one is a closed island because on all sides is surrounded by water. Here is another closed island. Again, this island is completely surrounded by water on all sides. Now, this one here is not a closed island because although there's water on these sides, it's on the edge and the edge side doesn't count. So we're looking for islands that are inside the grid and the four sides are touched by water. So on this grid, there are a total of 2 closed islands. So this question, it's very simple. All we have to do is find all the lands on the edge. So these guys and these guys, and we want to change them to ones because it won't be counted anyway. So we're going to change that to water. That will be the first iteration. And the second iteration, we come in and we find all the islands that are not marked in the first iteration. And then we count the number of these closed islands. Okay, let's take a look at the code. This C# code is provided in the GitHub links below. First, I would define 2 parameters, the number of rows of the grid and the number of columns on the grid. The number of rows of the grid is here and the number of columns on the grid is here. And then I will iterate every cells in the grid and I will find all the edge cells. The edge cells are those cells that are on the first row, on the last row, and the first column or the last column. So I will find all the edge cells that are also land. So with the value of 0. And once I find these, I would call a recursive function visit cell. This recursive function will first check whether the coordinates, the I and j's are valid. Being valid means that the I and j values are within the range of the number of rows and the number of columns, and also they are land. So once I find the land tiles that are on the edge, I will call this function. After it checks its coordinate, then I would convert these tiles to ones. I will convert them to water. And then I'm going to recursively call the same function for the neighboring cells on the top, on the bottom, on the left, and on the right, passing in the new coordinates, a new set of I and j's. So what these recursive call would do is that they will also visit a neighboring cells if they are within the range of the grid and also if they are land. These recursive call would then convert those tiles to water as well. The visit cell function would pass in a new set of I and j's each time. And some of these coordinates, the new coordinates, would be coordinates that lie outside of the grid. So that is why the isValidCell function is there to check whether these coordinates lies beyond the boundary of the grid. And if it is so, it would not make that recursive call. After the edge cells are processed, I would iterate the grid again with the second set of double for loop. This time, I will look for tiles of lands that are not attached to the edge cells. Remember, in the first set of iterations, all the land tiles that are associated with the edge cells were already converted to water. What remains now are, by definition, pieces of land that are part of the inner islands in the grid. So once I find a piece of land on the inside, I will increase the total count by 1. And then I'm going to call the visit cell function. Calling the visit cell function would recursively find all the adjacent lands and convert these tiles to water. So down the road, these will not be visited again. And that's it. So 2 double for loops and then return the number of total closed islands found. Let's talk about the runtime complexity. The first time, the double for loop will iterate the grid and find all the tiles that are on the edge. The second time, it will find all the inner island pieces. So each tile was iterated at most 2 times. So the runtime complexity is big O of the size of the grid. Okay, let's check if it works. And it's good. See you next time.